imagine we're on a mission in the most advanced spacecraft ever built, slowly inching our way towards the sun. What would we experience? First, let's leave Earth. As we travel, the sun grows larger and brighter in our view. Even from Earth's orbit, 150 million kilometers away, we have to deal with solar radiation. Astronauts on the International Space Station are already exposed to more radiation than we are on the ground, thanks to our protective atmosphere and magnetic field. Our hypothetical spacecraft would need incredible shielding just to handle this baseline level of cosmic and solar rays. Let's fast forward a bit. We're now at the orbit of Mercury, the innermost planet, about 58 million kilometers from the sun. Here, the sun appears 2 to 3 times larger in the sky than it does from Earth. The intensity of sunlight is about 7 times greater. Without protection, you'd get a lethal sunburn in seconds. The temperature on the sunlit side of Mercury can soar to 430 degrees Celsius. That's hot enough to melt lead. Our spacecraft would need a seriously powerful cooling system and a highly reflective shield, something like the Parker Solar Probe's heat shield, but designed for a human crew. This shield would have to face the sun at all times, keeping the rest of the craft in its shadow. But we're not stopping at Mercury. We're pushing onward, getting closer. As we do, the dangers multiply. The solar wind, a stream of charged particles flowing from the sun, becomes a hurricane of radiation. These particles, mostly electrons and protons, would batter our ship. The radiation levels would be off the charts. We'd need thick layers of shielding, perhaps made of materials rich in hydrogen, like water or polyethylene, to absorb the high-energy neutrons and other particles. The crew would have to live in a heavily fortified storm shelter deep within the ship. Now we're getting really close. Let's say we're about 20 million kilometers from the sun's visible surface, the photosphere. The sun in the sky would be a colossal, blinding disk. The solar intensity here is about 56 times what we experience at Earth. The heat is unimaginable. Even with a perfect heat shield, some of that energy would inevitably leak through and heat the spacecraft. Our cooling systems would be working overtime, glowing red-hot as they radiate excess heat into space. Inside, things would be getting tense. The constant bombardment of radiation would pose a severe, long-term health risk, even with shielding. The psychological toll of being cooped up in a tiny, shielded room with a giant fusion reactor blazing just outside your window would be immense. Any tiny failure in the cooling system or the heat shield would mean instant disaster. Let's keep going. We're now inside 10 million kilometers. We're closer than any spacecraft with active electronics has ever been for a sustained period. The Parker Solar Probe zips through this region, but it does so at incredibly high speeds, minimizing its exposure time. We, on the other hand, are on a slower, more deliberate approach. At this distance, the sun's gravitational pull is becoming a major factor. We'd need powerful engines firing constantly to avoid getting pulled into a closer, faster orbit, or worse, into the sun itself. The environment here is extreme. We're flying through the sun's corona, its outer atmosphere, which is bizarrely hotter than the surface, reaching millions of degrees Celsius. While the gas is very thin, so it doesn't transfer heat in the conventional way, the charged particles are moving at incredible speeds. They would strip atoms off the surface of our heat shield in a process called sputtering. The shield would literally be eroding away, molecule by molecule. Okay, let's get to the final stretch. How close can we really get? The key isn't just surviving the heat, but surviving the point where our spacecraft itself fails. The limit is determined by the materials we use. The Parker Solar Probe's heat shield is made of a carbon-carbon composite, which can withstand temperatures up to about 2,500 degrees Celsius. Let's calculate the distance where our shield would reach that temperature. The intensity of the sun's radiation drops off with the square of the distance. Using some physics, we find that at about 3 million kilometers from the sun's surface, the heat would be so intense that it would push even the most advanced materials to their absolute limit. At this distance, the sun would take up a massive portion of the sky, about 35 degrees wide. It would be a terrifying, awe-inspiring sight. Any closer than this, and things go bad very, very quickly. At around 2.7 million kilometers, the front of our carbon heat shield would begin to vaporize. It would sublimate, turning directly from a solid into a gas. The shield would start to thin, and soon it would fail completely. The moment the shield is breached, it's game over. The concentrated sunlight, thousands of times more intense than at Earth, would flash through the spacecraft. Metals would liquefy and then boil in milliseconds. The hull would be breached and the vacuum of space would rush in. But you wouldn't even have time to notice that. The sheer energy flux would hit you. The human body is mostly water. When exposed to that level of energy, the water in your cells would instantly flash to steam. This isn't like being burned. It's more like being in the center of an explosion. You wouldn't feel pain. Your nerve endings would be vaporized before they could even send a signal to your brain. You, the spacecraft, and everything inside would be turned into a rapidly expanding cloud of plasma in less than a second. So, the final answer? With the most advanced technology we can realistically imagine today, the absolute limit of approach would be around 3 million kilometers, or about 1.8 million miles, from the surface of the sun. You could get tantalizingly close, close enough to see the churning, violent surface of our star in breathtaking detail. But that's the hard stop. Any closer, and you join the sun, becoming one with the very star you came to explore. It's a humbling reminder of the incredible power that gives us life from 150 million kilometers away. Thanks for joining me on this cosmic trip. If you love thinking about these wild space scenarios, make sure to like this video and subscribe for more adventures into the unknown. Remy signing off. Stay safe and stay curious. See you next time.